Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 10th. First up, we take a look at significant wave heights for the North Pacific Ocean. We see remnants of a gale in the eastern Gulf of Alaska from a storm previously that tracked over the dateline, made pretty decent sized seas. Swells from this system is poised to move into the California coast shortly and has already passed Hawaii. Another system developing in the western Gulf, not very impressive, 28-foot seas, and yet a third system stacked up here off the Kuril Islands, barely 30-foot seas over a small area. But this seems to be the theme now, is rather small, not even necessarily potent storms, but just small systems tracking west to east. Let's get into the details. First up, we'll take a look at jet stream level winds. These winds, up about 30,000 feet, help support the formation of gales, and when those gales do form, help direct their track. What we're looking for is a trough. That is something like this, a little dip in the jet heading to the south. That helps promote a counterclockwise flow aloft and down at the surface, and of course that is the sign of low pressure, and low pressure is what makes winds and what makes swell, and of course makes surf. So here we go. We have again a reasonably consolidated jet stream flow pushing well to the south, in between about 30 and 35 south, off Japan, moving over the dateline, making it to a point, about halfway in between Hawaii and the U.S. West Coast before it splits. This split here helps support high pressure aloft, which is providing just a modicum of support for a rather calmer pattern along the U.S. West Coast. But back, if that split were to move on shore, the assumption would be that the storm door would be wide open and there would be copious amounts of rain and weather moving into the U.S. West Coast. Right now, that is not so much the case, even though remnant energy does bridge the gap here and work its way into the coast, and that appears to be the pattern for the coming week. Also notice that winds, though they are pretty solid right here in this one pocket up to about 160 knots, are rather kind of not filling the entire area, but just in little spotty areas, and we suspect that is what is contributing to the rather small and not large lumbering low pressure systems. So let's put this into motion, roll this out. We see the wind pattern starts developing reasonably Monday night, building stronger, almost 190 knots in one spot there, but reaching pretty well from Japan over the dateline, almost to a point north of Hawaii, but not exceeding that. Another trough develops here come Thursday. That would support low pressure development there as well. And we'll roll this out. We'll see whether, and notice you sort of get this split thing going as the jet, as this trough develops. But either way, remnant energy always seems to work its way into the U.S. West Coast. Then winds back off again come Friday night. And then it looks like it tries to develop again over the weekend, but nothing just super impressive, just kind of moderately there. Really what you want to see is like 180, 190 knot winds here, working almost right up to the U.S. West Coast. That would be the sign of a really well-entrenched El Nino pattern. But still, given any other normal winter, this is a great pattern. Also notice here that come 180 hours out, at least in this frame, the jet is supposed to fully come onshore with no split off the coast to protect the U.S., so maybe a wetter pattern long term. Let's take a look down at the surface now. So here we go, surface level wind, surface level pressure, and what pops up immediately in the view is that basically the entire North Pacific Ocean is full in some flavor of low pressure. One system here off Japan, another in the middle of the Pacific, another in the Gulf of Alaska. Also notice Tropical Storm Polly, just north of the Kelvin wave generation area. Very unusual to have a tropical system in January, to say the least. All attributable to westerly winds and westerly wind bursts that is occurring in the Kelvin wave generation area. We'll get into that a little bit later. Right now, in terms of swell production, let's roll this out. We see one gale there, 3 gales, 4 gales, but they're all very small, a little bit of, just very tiny little systems. This one here we get into Monday night, stronger system off of Kamchatka, covering a little bit broader area. Let's see what it does. It tries to organize, but just doesn't quite have, there isn't quite the wind energy there in the jet to support it. Now let's go back to Wednesday. A new gale develops pretty much on the date line and pretty far south. A better patch of 55-knot winds, somewhat targeting Hawaii. This has been the pattern of late. They form here, sort of give a glancing blow in terms of fetch aimed at Hawaii, and then more towards the U.S. West Coast. As they work their way towards the coast, the split in the jet pushes them to the north, and then they end quickly. And this one pretty much does something very similar to that into Friday. And then another one picks up on Friday night, moving towards the U.S. West Coast, but again gets deflected to the north. Just a little patch of high pressure right here, providing minimal protection. And then you see yet more developing. I mean, it's just like a machine. It just goes on and on. This one a little bit stronger at 180 hours out. 55, almost 60-knot winds here approaching the date line from the west. Will be interesting to see what happens. But based on what we saw in the jet stream, it doesn't look like a whole lot of change in the pattern. Also notice 180 hours out, Tropical Storm Pally still in circulation here, just north of the date line, at north of the equator at the intersection of the date line. Very interesting indeed. This would speak to continued westerly winds, and you actually look here and you can see westerly winds at 15 knots, but we have a far higher resolution tool to look at that. We'll get there in just a little bit. And then finally, the effects of those winds on the ocean surface, generating seas, significant seas, that is. And currently we see a pretty good patch of seas right here at, what is that, about 25 feet, little patch of 26. This from a gale that developed just a couple days ago. In fact, let's go back and take a quick look. So here we are into Friday, January 8th. Small gale develops on the date line, roughly, southern date line region. Gets pretty good by late Friday. We're into, 43-foot seas with winds in the 55-knot range right here. Again, aimed more of a glancing blow at Hawaii. Most energy right up the Great Circle paths to California. We'll roll this out. Seas build to 46 feet, right in about, somewhere early Saturday morning. Again, tracking right towards the U.S. West Coast. Swell, you can actually see seas, not just swell, but seas moving into the Hawaiian Islands on Sunday. And then by Sunday evening, this system, as we just saw, winding down, but still getting a pretty good footprint. Swell from this system is expected to move solidly into Oregon and California for the early part of the week. And then moving forward here, we go into Monday morning. Again, here's our string of three little systems. Nothing really super impressive, just continued agitation of the North Pacific, but not in a broad and forceful manner. And then we get into Wednesday. New system develops here north of Hawaii, 30-foot seas, and then builds up to about 43-foot seas with 65-knot winds over a small area here. That's Thursday morning, the 14th. But again, same sort of pattern, though there is, notice this, 28-foot seas, 29-foot seas behind it. Again, pushing a good patch of sideband energy towards Hawaii, but also towards the U.S. West Coast. This system winds up and is pretty much done by Friday, fades out, but swell will be working towards the U.S. West Coast, already hitting Hawaii by Friday evening for sure. And then we go back to this just sort of continued small systems, a stronger one building here, and of course seas from Pali still in play if one is to believe the GFS model. So all in all, a pretty respectable swell pattern is forecast for the coming week, though nothing super over the top. The strongest one probably is the swell moving towards the U.S. West Coast for later Monday and Tuesday, but then that other system we saw, one is that like Wednesday, Thursday, offers some good potential as well. Let's take a look long-term at El Nino and see how that is doing. That will certainly affect swell production for the coming months. So first up, we'll take a look at winds down at the surface, particularly in the Kelvin wave generation area. That is from about 135 west on the equator, 135 east on the equator. Basically, there's New Guinea out past the date line to about 170 west, this little box right in here. It is west winds in this area, or west anomalies, that signify the active phase of the Madden-Julian oscillation when the MJO is in the active state, which tends to last for about 3-4 weeks at a time, and then it'll go inactive for 3 or 4 weeks at a time. When that happens, it tends to impart energy to the jet stream, and then as the jet ramps up, that helps support storm formation, especially in the dateline region into the western Gulf of Alaska and the Gulf, and that's what we look for. Now that we are in an El Nino state, westerly winds or westerly anomalies tend to be almost a steady diet. The interesting thing about this year's El Nino is the MJO, which is normally dead in super El Ninos, appears to be still in play. So we're getting this sort of on again, off again, 3-4 weeks at a time phase of westerly winds, and then they die out and the jet stream sort of falls apart. Right now, we're smack dab in the middle of the active phase of the MJO. As you can see, westerly winds identified here by these arrows from the west, of course. And then westerly anomalies, very strong westerly anomalies. That is differences in normal for this time of year, very much from the west and very strong, clearly indicating something more than just the active phase of the MJO, clearly indicating an El Nino pattern enhanced by the active phase of the MJO. And in fact, here we can look at this chart. These are 850 millibar winds. That's up about 4,000 feet. And the Kelvin wave generation area, again, 135. So there's New Guinea. So and the equator is right here. So roughly a box from here to here. And you notice the westerly winds are actually displaced well east of the Kelvin wave generation area. This is pretty typical of the later phases of El Nino. Early in the year, you get more your westerly winds out here, but a little bit of time, over time, they work more and more and more to the east, and then eventually collapse at the end of the El Nino cycle. Anyway, January 4th and 5th and 6th, and 7th and 8th, you see that just continued westerly wind pattern. Here's the equator right here. So, the date line right here. So basically just completely locked down right on the date line. Very good, very much feeding El Nino, very much feeding the jet stream. We'd like to see a little bit more of that, but basically everything is in alignment per these charts and has been for a little bit now. So here's the GFS model. High res. Here is the Kelvin wave generation area. The core of it, 3 south to 3 north, but the totality of it goes up to, we call 5 north and 5 south. Here, the date line is way over here, and there's a 2-frame. We've got another one that goes out over here, another model that we'll look at in a second. Anyway, what you see here is easterly winds in the northern part of the Kelvin wave generation area, pretty much light west winds down here. So it's pretty normal to have east winds in this area this time of year. So this is not an unusual thing. We'll roll this out. But what you do see is westerly winds building here right on the date line come, Monday night, Tuesday. We'll roll this out. Notice they get very strong down up to about, 18 to 20 knots come Wednesday per this model, and even a little bit stronger. And continuing there, 20 knots to 22 knots into Thursday, and then this sort of just continues like this, fading a little bit, oscillating some. And notice the easterly winds continue here in the north, but otherwise it's pretty much a dead neutral pattern with westerly winds right in this area up to 180 hours out. And then here is the second part. Here is from the date line east. Here is the Kelvin wave generation area. Here is Tropical Storm Polly. Here with, per the model, winds in the 35 to 40 knot range. We'll roll this out, and this is very interesting. Notice your westerly winds here in the, right in the core of the Kelvin wave generation area. And notice how Polly, per this model, is to actually fall south into Tuesday and into the Kelvin wave generation area solidly with winds in the 55 knot range. And we'll just continue to roll this out. Very strong westerly wind pattern projected into Thursday, Friday, Saturday, maybe fading out a little bit come Sunday, but still just very solid. And this is still in the northern Kelvin wave generation area. Up to 180 hours out. So that's an interesting picture. Now we'll contrast that some with the official forecast here. Here is the positions and basically of Tropical Storm Polly for better part of almost a week now. All at depression, tropical storm strength. Now here's the forecast, and it also suggests that as the week continues, Polly's disposed to fall to the south. But notice the wind speeds here. When the GFS model was showing winds in 45, 50 knot range, this is suggesting a steady decrease in wind speed down to tropical depression status. What's that? That's only 5 days from now. So a bit of a difference between the GFS model and what other models and human intervention says is the outcome. It will be interesting to see how this plays out. The other part here is also note the GFS model, for whatever you want to say, has this tendency to overhype systems out into the future, and then the closer you get to reality, it tends to reel in the expectations, not only in terms of wind speeds and precipitation amounts, etc., etc. So not a perfect model, but it is the best we have at this point in time. And yet one more view of the wind situation. This is going back in time, December 11th, and this is the whole globe. The Kelvin wave generation areas pretty much draw a line down here, and reds and oranges and whites are westerly anomalies, if not out-and-out westerly winds. The blues, like here, are easterly anomalies. This is over the very far western Pacific and Indian Ocean, pretty normal for El Nino. The point being here, come start about December 19th or so, we started getting this westerly wind pattern. This is when the active phase of the MJO set up. By the time we got into late December, we were in what we would call westerly wind burst mode, full-on westerly winds down at the surface. And now here is the forecast. We are right in the core of what is considered to be a significant westerly wind burst. And then about a week from now, that's supposed to start winding down some once we get into about January 17th or so. So one would expect the jet stream should be doing its maximum thing right about now. But when we looked at the jet stream charts, we see it's solid, but not super impressive from an El Nino, certainly from a super El Nino perspective. But still, you take what you got, it's not bad at all. Anyway, so the other part of this is westerly wind burst. One would expect a Kelvin wave to result, maybe. But you know what? The reality is there's not a whole lot of warm water left over here in the West Pacific because of previous westerly wind burst. All that warm water has been migrated east. It's in the form of Kelvin waves, and we'll get into that in a bit, and erupted over the Galapagos Islands and just west of there. And so we're in the heart of El Nino now. And the reality is one would not expect a Kelvin wave to be built at this late in the game. But still, the atmosphere is trying just the same. Good situation indeed. So we've talked about the active and the inactive phase of the MJO. This is outgoing long-wave radiation, that is sunlight reflectivity off the ocean surface. The active phase of the MJO typically promotes a lot of cloud cover, less sunlight reflectivity off the ocean surface, and so it's depicted as this. The oranges and the reds are consistent with high pressure and the inactive phase of the MJO, and as one would expect, it is sitting here over Indonesia. Active phase here, this per the statistic model, over the date line. This model suggests that over the coming 2 weeks, the active phase of the MJO is to move east and fade out, with the inactive phase of the MJO moving into the West Pacific. That would suggest a decline in the jet stream and a decline in storm production about 2 weeks out. The dynamic model paints a little bit different picture. It suggests that the active phase is to hold, fade a little, and then regenerate, with the inactive phase staying basically stationary, if not retrograding a little bit. Not sure if this is completely believable. Not sure if this is completely believable either. Maybe somewhere between the two is the expected outcome. Another way to view the situation, these are these phase diagrams, if you will. Indian Ocean here, we're going to go around the planet from the Indian Ocean to the Maritime Continent to the West Pacific, then over the U.S., and Europe and Africa, and back around the globe. This chart depicts where the active phase of the MJO is. This is past history. Currently, it's suggested that it is here already, hard to believe, over the Americas, if not beyond, and is supposed to continue and work its way into the Indian Ocean 2 weeks from now per the ECMF model, and basically the same thing per the GEFS model. Perhaps, if this is in fact the case, and this is where the active phase of the MJO is, then that would suggest that all the westerly winds that we're seeing right now are actually attributable to just El Nino all by itself, and that if that were the case, that might explain why westerly wind, or why the jet stream is maybe not as strong as one would expect if it were in sync with the active phase of the MJO. But a little bit of a disconnect here is what it appears like. And yet one more set of phase diagrams with a whole bunch of different models here lined up, so you can sort of see what all the models suggest, and they're all suggesting some sort of eastward movement of the active phase of the MJO moving into the Indian Ocean 2 weeks from now. And yet one more model look at this situation. So we've seen this one before. Now past history is here, September 12th, working its way into the future. We're looking at westerly winds or westerly wind anomalies, and going back in time, we see a very strong westerly wind burst that occurred in the October time frame. That created Kelvin wave number 4, the largest of any of them. Then things sort of died out here. As you can see, westerly winds backed off. And now here we are in the middle of our major westerly wind burst right now, and let's overlay the MJO so you can see what's going on. Currently, per this, the CFS model, the active phase of the MJO, or at least the way it's manifest in terms of El Nino, it's right here, right over the date line, driving westerly anomalies, and expected to continue to do that into towards the end of January. Notice another westerly wind pocket here. We'll go look at Rossby waves, and we see a little bit of a Rossby wave right there interacting with the active phase, almost the active phase of the MJO, maybe goosing it up just a little bit. But then we get into this time frame, we'll say the end of January into about the end of February. The inactive phase of the MJO comes in, westerly winds get suppressed. The thought would be that the storm cycle would back off in that time frame to some degree. But then the model has consistently been suggesting that come about the 1st of March, the active phase of the MJO returns again, westerly anomalies ramp up. Now notice these westerly anomalies are all right around the 180 longitude mark, right on the date line there, which again, we don't expect that it would create Kelvin waves, but it would help support the jet stream and fuel storm production and therefore surf production, and also possibly weather moving into the U.S. West Coast. So that's and this pattern has been pretty stable. January was expected to be a stormy month. February has been expected to back off, and then the March time frame, things were supposed to ramp up again. So no big change, really, just small details. So we've talked about westerly winds and the MJO and driving the jet stream and all that, but the effect of westerly, so this is the West Pacific, this is the East Pacific, this is the surface, this is at depth. Westerly winds at the surface or westerly anomalies help move warm water, which is normally all pooled up over here in the far West Pacific, to the east. Clearly we can see a giant pocket of 29-degree anomalies working their way to the east, and the 28-degree isotherm here, right, just barely hanging at 120 west, and that's as far as it's made it at all in this El Nino. And it's actually retracting a little bit. There was a pocket of 30-degree anomalies here or 30-degree temperatures, that's centigrade, but they have faded. None of this is surprising, but this is clearly showing that warm water has migrated to the east. Now, anomalies, differences in normal for this time of year. Clearly, there is a pocket of warm anomalies here in the East Pacific. The Galapagos would be off over in this region somewhere. And clearly, we see warmer than normal temperatures, 2-degree anomalies, just retracting some from the dateline region. We also see, normally, here's where all the warm water, this warm water here, should be all balled up here. It's migrated here. The cool water that's normally over here, caused by upwelling, caused by easterly winds that push off the Galapagos and Peru and that area and Ecuador, have been replaced by the warm waters that were in the West Pacific. This is classic El Nino setup. A great big pocket of cool water here, big pocket of warm water here, but notice temperatures are down. They were up to almost 8 degrees at one point. Now they're at 5 degrees. This reservoir is steadily getting smaller. Even though we have strong westerly winds blowing, notice there's no real warm water here or anomalously warm water here. I mean, there is some. Whatever's here is trying to bleed into this area, trying to get a Kelvin wave going, but the reality is that it can't compete with the warm water and the westerly winds that were here earlier in the year, and as a result, this reservoir is slowly bleeding out and drying up and fading. At some point, it will all be gone, and it will collapse, and that will be the beginning of the end of El Nino, at least from an ocean perspective. In the atmosphere, though, it will take months, if not a year, for all the I will say the damage that's already done. It's good damage as far as surfers and people that are looking for rain and snow in California. It's all a good thing. It'll take a year for that to reverse itself and fall back into at least a normal pattern, if not a La Nina pattern. This chart depicts sea surface height anomalies, differences in normal for this time of year. Strip out all the waves, strip out the tides, strip out any effects of gravity and whatnot. And basically, it is a proxy for warm water down at subsurface. Warm water at depth expands and therefore creates sort of a bulge on the ocean surface. You can measure it. The Jason 2 satellite here makes a bunch of passes over the Pacific Ocean and can detect anomalies, differences in normal from the ocean height. Clearly we see below normal heights here in the West Pacific, consistent with cooler than water temperature, as we saw in the previous chart. And clearly we see above normal heights here in the East Pacific, consistent with a large pocket of warm water in this area, but not as warm as it was. We had a good pocket of 15, even at one point up to 20 centimeter heights above normal in this region. Things are slowly ramping down, but still very respectable. In any normal year, if you saw this, you'd be going, "Oh my gosh, this is a big deal." And clearly it is. Clearly, it's a signature of El Nino. And here the high-res subsurface view, basically showing us what we saw before. Cool water in the West Pacific, encroaching, trying to work its way east, trying to undercut the warm reservoir, but not completely cutting it off. Clearly still 5 little pocket of 6-degree anomalies in this image, and basically extending from the date line, if not a little bit west of the date line. Westerly winds in this area, pushing whatever warm water is here to the east, trying to get it to backfill into this reservoir, and that's all a good thing. So we also know from, we've talked about this in the past, this warm water eventually, because it's like a Kelvin wave, it starts erupting at the surface near either Ecuador or the Galapagos Islands, and clearly we're seeing some signs of 4-degree anomalies right here at about 100 west, working their way towards the surface, and then it forms a big warm water slick on the ocean surface, on the equator, from about Ecuador, somewhere south of Hawaii, if not more, and that is the classic El Nino signature. Clearly, this depicts a subsurface picture that would support El Nino. And of course, our favorite chart, upper ocean heat anomalies, because with this chart, you can actually see the movement of warm water. So if you have westerly winds here, you can see warm water moving from west to east in the form of a Kelvin wave. First Kelvin wave this is actually part of a Kelvin wave that happened last year, 2014 we're talking about. 2015, Kelvin wave number 1. In the March-April time frame, Kelvin wave number 2. In the June time frame, what we thought was just a massive Kelvin wave number 3 in the August-September time frame, working its way into the Ecuador. And then even stronger, larger Kelvin wave number 4 that occurred in the November time frame. It has done its thing. Also notice these little pockets here of cooler water, if you will. This is the upwelling phase of the Kelvin wave cycle. It doesn't show up between every Kelvin wave, but it clearly looks like now we've had a bit of a break. We had the inactive phase of the MJO in the November time frame, pretty much all of November, the first 2 weeks of December. Shut down westerly anomalies. Even though El Nino was trying to do it, it just wasn't quite there. But now we have our westerly anomalies back in play. Notice here a little bit of warm water starting to show up on the chart. trying to maybe suggest Kelvin wave number 5 is forming, but we thought we saw that here before. We'll see. We'll see what happens. You know, it's going to take another couple of weeks at least, if not a month. But anyway, at some point we would expect to see something like this maybe show up here over Ecuador later in January, again due to the inactive phase of the MJO. But we'll see. Either way, we don't expect another Kelvin wave, not a solid Kelvin wave, certainly not like that to result, but maybe we'll get lucky and see at least warm waters continuing subsurface. But of course, it's where the rubber meets the road that really counts, and that is getting warm water to build up. Here's the Galapagos, Mexico, Central America. It is warm water buildup in this area right here that is the classic sign of El Nino. The really interesting thing about the January 9th image is notice here these pockets of 4 and almost 5 degree anomalies. They weren't here a couple of days ago, and we had basically written this thing off completely and just said we're not going to see any more of those 4 degree anomalies. We were perfectly happy just seeing 3 degree anomalies, but they're starting to come back now. Very impressive indeed. This El Nino appears to have some magical staying power right when you're about to write it off, and by not in a bad way, but just say the peak of the warming is over. It comes back again. It did it in I think it was the September time frame, then it did it again in October time frame, and now it's been just on and off and on and off. Again, this is not anywhere near as strong a warming signal as we had a month or two ago, but still very impressive for January. We'll take it. And the 7-day trend also is quickly picking up on this. Notice all these pockets of warming starting to show up here, basically, and south of into Peru and Chile as well. But it is really this stuff out here that is most interesting, suggesting that warming again, eruption of the subsurface reservoir is pulsing again, imparting more warm water into the El Nino surface warm pool. And that's good because that will only help to strengthen the jet stream, make it more consolidated, and to push more warm water or more energy into the jet and support storm formation. And one other quick point back on the previous chart. Remember earlier in the year, all the warm water that was built up off here? Notice that most of it's gone now, the quote-unquote blob. It was never expected to do anything. This is exactly what we expect as storms start marching off Japan. They'll start mixing ocean surface here. You'll start seeing water temperatures cool here. It'll be warmer here. Bit of a gradient between the two. That actually helps support storm formation, and the storms theoretically get stronger and more powerful, and therefore create more surf and more rain and precipitation. So we'll go sector by sector, looking at sea surface temperature anomalies here. Ecuador right here, Galapagos right here, and clearly we see 2.25 degree anomalies, but no 4 degree anomalies in this area, and we haven't really ever. For the most part, the warming is displaced west of the Galapagos. During the 97 El Nino, this area was just cooking warm. This year's El Nino, not nearly cooking as warm here in the Nino 1.2 region. Most of the energy is all westward displaced. Just differences in El Nino, that's the way it is. We go back a week and just look at the change in pattern, and the reality is not a whole lot's changed. Things are staying pretty stable. If anything, look right here. Things are building a little bit, but again, most of it's to the west of the Galapagos. Then we head to the west from, let's say, 100 west out to 160. The Nino 3.4 region, the main area for monitoring El Nino, is 120 west out to 170 and 5 degrees north or south of the equator. Still a very respectable presence of 2.25 degree anomalies. No 4 degree anomalies showing here, basically the whole way from the Galapagos on out. But let's go back a week and take a look. Notice there here, right in the core of the Nino 3.4 region, temperatures were solid a week ago. Now we have a bit of a break going on here. And also notice we had warmer temperatures back here. They've kind of dissipated, but we have a little bit more width developing here. So maybe it's a 6 of one, half dozen of another. It's the total aerial coverage of all temperature anomalies in this area that drives the actual temperature or the index for the Nino 3.4 region. And then the final segment going from out to, let's say, the date line or so. Still warm waters. 170 is the cutoff for the Nino 3.4 region. Yes, looking good. We go back a week, though, and you can see that we've lost some coverage compared to a week ago. But nothing too overly significant. And then finally, the mid view. This is from January 2nd. Notice it was these final little pockets of 4-degree anomalies that were almost gone a week ago. And now here we are. And look at this. We have much more of them. We actually have some 5-degree anomalies, little tiny pockets buried in there. So this is, again, impressive. More warming, more eruption occurring of warm temperatures out at around, about 115, it looks like. When we saw the subsurface view, is right around 100 is where we thought most of the warming was occurring. But clearly that is an imperfect view. All this is coming from deep down in the ocean. Again, a very unmistakable El Nino signature. And then the average over time, there's been a lot of noise here in the Nino 1.2 region. This is the region closest between the Galapagos and Ecuador. And again, not a super strong El Nino. I mean, clearly warm here, but just not a super strong El Nino signature here. Current temperatures up to plus 1.9 degrees. The Nino 3 region, which runs between the Galapagos and out towards the dateline, but not completely there, has been just rock solid, currently plus 2.577 degrees, just above 2 degrees, and this is in the very strong El Nino category, and consistent. This is a good indicator of what's going to go further west out at Nino 3.4. And here's Nino 3.4 at plus 2.247 degrees, slowly tapering down as one would expect given all the subsurface data and everything that we've seen, but still very respectable indeed. Right here, it's half a degree is considered El Nino. We're way, way, way beyond that point. We're up in a very good place indeed. But clearly, the peak of El Nino, according to this, was in terms of just warming, was in the November-ish into maybe early December time frame, and that's consistent with all the other data we've seen. Now, it takes a while for these warm waters to actually start having an impact up in the atmosphere. There's a delay of a month or so. But clearly, we should be in the peak of things right about now. So finally, we start talking about coupling, the coupling of the El Nino with the atmosphere. That is, westerly winds create westerly wind bursts, or westerly wind bursts create Kelvin waves. Kelvin waves push warm water to the east. They erupt in the Galapagos area, create a warm pool there, which in turn imparts energy to the jet stream, which in turn helps drive the storm track. So you want to see signs of the warm pool having an effect on the atmosphere. One way of doing that is with the Southern Oscillation Index. Difference in pressure between Darwin, Australia and Tahiti. One would expect to see low pressure in the Tahiti area because that's where all the warm water is, and so it should fuel thunderstorm development, tropical storm development, like Tropical Storm Polly. Classic example of westerly wind burst El Nino induced atmospheric changes in January of all things. And clearly here we see, so what you want to see is this index go negative, and clearly it's been doing that. Now, it was positive in the early December time frame until the active phase of the MJO started integrating with El Nino, and boom, right when that happened, then here you go, SOI went negative, and today it's at minus 23.6. The 30-day running average, notice it, is, here we go, it was like in the -9 range, still indicative of El Nino, but now down to -12. We want to see this go to about -20, and the 90-day running average was actually rising. It now is starting to sense the change in the daily numbers, and it too is dropping to -11.61. We want to see it go down to like -15, -18, somewhere like there. Don't know if that'll really happen or not, but still, this clearly indicates some form of El Nino pattern in play. Likewise, there's the ESPI index, and here you go. It measures total cloud cover between just north of Darwin here and total cloud cover here above where the warm pool would be. The more positive the number, the greater the El Nino signal is. If this were negative, then it would suggest La Nina, but positive numbers suggest lots of clouds in this area. Today's value is at 2.28. It was at last week I think it was about plus 1.8, and it has been steadily rising, suggesting that the atmosphere is getting more and more coupled with El Nino. In fact, it's actually quite, pretty far up there for where we are in the season. This is actually a good sign and kind of unusual. It just suggests that, and here's the anomalies. You can actually see more cloud cover here just north of Tahiti. Again, all this suggests is that our El Nino is pretty well coupled with the atmosphere. But then there's the gold standard, what we consider the gold standard, the MEI. So what this does is it takes a bunch of signals, the Southern Oscillation Index, sea surface temperatures, you name it, throws it in a big pot, stirs it up, and also calibrates it based on year to year. So you can, because the oceans are warming continuously, and so warm temperatures from the 50s are, what was warm in the 50s is cool by today's standards, but it calibrates all this and sort of, normalizes it, if you will, so you can compare one El Nino to the next. So this year's El Nino, or this month's MEI value for December is 2.12, actually down a little bit from where it was, okay? But what this does is, here is the 97 El Nino, here's the 82, 83 El Nino. To be a super El Nino, at least according to this system standards, you have to be up to 3 standard deviations from normal. We clearly are not there. We're at about 2.1 standard deviations. We are up here about almost 2.5, 2.4, but still that's not enough to make super El Nino status, just strong El Nino status. So according to this one, this suggests that this El Nino that we're in is the 3rd strongest El Nino since the 1950. That's when they started, we had a good, reasonably scientific basis to track El Nino. So very, there was a lot of hype, Godzilla, El Nino, and all that kind of stuff suggesting, this was going to be a super El Nino. And we thought actually it might reach super El Nino status. But the inactive phase of the MJO in the November-December timeframe pretty much put the squash on that. I mean, maybe you notice here both the 82 and the 97 El Nino sort of rebounded some in the February, March, April timeframe. We might see some of that. Will we get to a 3 sigma, 3 standard deviation level? I'd say that's pretty much of a reach, but still, 3rd strongest El Nino in modern history. Can't sneeze at that. Pretty good thing indeed. So to wrap things up, Storm track still quite healthy. Jet stream looking good, not super strong, but solid indeed, consolidated. Series of storms. Forecast for the coming week, more swell expected, actually more rain, also expected for the U.S. West Coast, snow in the higher elevations, bring it on, build the snowpack, that's exactly what we need. This El Nino's signature character has been slow and steady and persistent, not overtly impressive at any instant in time, but just this, it's like the tortoise and the hare race. This El Nino has just been the tortoise. It just keeps on going and going and going, and that is, that's what we saw early in the year. That's what we're seeing in terms of the storm track and everything else. So we're not writing this guy off by any stretch of the imagination. Lots more to come. We are just barely getting into winter with the active phase of the MJO forecast in March. Who knows? We could have a really big late season rally. But right now, things are chugging along very nicely. El Nino progressing, storm track progressing, all looking good. So the point is, go get surf when you can in between the storms, depending on where you live. Hawaii's been doing pretty well just on its own without quite so much weather. All a good thing. Take it, enjoy it, have a good time, be safe. There has been some supersized surf and some supersized injuries as a result, so be careful, know your limits, but that's it for this week. We'll do this again next week, same time, same channel. Thanks for watching.